Yeah, so if I'm like the first uh, this will work.
Yeah, it worked. Okay.
Yeah, just
Anyone else also tried this notebook and failed from here, whoever is here? Okay. Yeah, you hang on.
yeah,
Just hold on. I'll just go to next cell. Let's fix this.
this one.
Actually, I fixed it. Did you can you pull the yeah, can you check the new code? So I think there was a problem in loading the Hugging Face token. So if you yeah, go over to this is the new code. So open this code again. So go at the top. Go
Over
at
the
the
top.
top.
Okay.
Yeah, and open in Colab. So that there is a button at the top,
Yeah,
right? Yeah, open in Colab. Okay,
I
and
just
it should have, yeah, so the Hugging Face token issue is fixed over here. So you can run this code again.
so I have to put the pause and so one second. I just pause this one.
Yeah, okay. Yeah.
Run.
So the problem might happen is you might run out of RAM. So you're using T4, right?
Yeah, yeah.
So yeah, so that would be
Actually,
a
I was
problem.
planning
Hmm.
to run it on Kaggle,
Yeah,
but
you have to run it on Kaggle and
I
then it will work.
uh, if it does
Yeah,
not work
because
now, I'll do it on
it will
Kaggle.
not work over here because you are on the free version of Colab and
Oh
it
yeah,
will
yeah.
so it's T4. So if you go and click on T4, see there is a gear sign over there. See how much GPU you have. Yeah. Yeah, click on it. Probably yes. See. So once you
Yeah, yeah.
start training, keep it open. So it will be good to look at it. How it will just shoot up to 15 GB very quickly. And then I can show my A4. So if you want to pay for Collab, then that's fine. Otherwise, you can try on Quick Kaggle.
Yeah, yeah. Actually, one of the, I think, if I'm not wrong, one of the fine tuning notebook had to run it on cake Kaggle because of like it was not
Yeah,
working on it.
yeah, it will
So
show you that error. So let's look into that error because that's mostly the problem that language model, even fine tuning, will not work properly on T4. So this the Onslaught code will work because they have created many layers. But here
mm,
we are not using Onslaught. So if you use Onslaught's model, they are
yeah.
actually the models that they provide have frozen many layers, and those will not be trained during fine tuning.
Mm.
So the number of matrix calculation will be reduced when you're using Onslaught. So with
Okay.
T4, when you are using T4, unsloth will be a good option. But
Yeah.
if you are simply running your own code without like just using QLoRa, it will still need A100.
Yeah.
So
The fuel aura, the first one which you had given, that
mhm.
one I had run on A400 in Cairo. So that
Yeah,
was not working
yeah,
in T4.
yeah. So
Yeah, what was
it will not work on T4. So
Mhm.
A100 is the minimum. So 40, yeah, that's the reason I mentioned there. So 40 GB of RAM is needed. So go over and hit it on Kaggle. I think that will be okay.
Fine.
Yeah. So let's see what's going on. And if it fails on the,
Yeah.
I think it will fail near the GPU RAM. So let's check how it's shooting up when it starts fine tuning the module. Yeah, so there was one, I think there was one property that I missed inputting, or maybe they keep changing the transformer codes actually.
Mm.
So that's the reason I the put one other the training I put one, what was that? Used it. Mm.
Another thing, in the board embeddings notebook, you had
Yeah,
given an assignment at the end, right?
yeah. So you
You
have
had to
to
make an
train it. Yeah, you have to train
yeah.
it.
So
Yeah,
like
so go ahead and train it. The best way you can work on, just put it there. Next week I will actually show my results and post it. Okay.
okay,
So
fine.
yeah. So whoever is working on that, please go ahead. In the meantime, I will start my code. It is 100. Oh, it's already running. Okay. Mm. Yeah. So in your auto, I think line number 80. Can you go to line number 80? Let's scroll up a little bit. Oh, okay. You don't have. So go to those three dots that will show up in your cell. In your cell. No, no, the cell. The code cell. Yeah. In the code cell, you see there's three dots after the trash, like onto the right hand.
Okay, yeah.
No, no, not those three. No, in the cell, coding cell.
Okay,
Do you see that? Yeah,
yeah,
over there. And it's not showing up. Okay, not here then. Just yeah, Chabda. So you have a gear sign over there, right?
yeah.
Yeah. So click on that. Okay. So
For
then
the line numbers.
yeah, show line numbers. Yeah. Always keep that open. That's easier to yeah. So now
18.
go to line number 80. So
Yes.
see this. If you so because it was also loading part of it, so we didn't mention which machine it should load, like which machine the tokenizers and all the other data it should load. So you have to explicitly mention over there that you need to CPU offload. So the last option is what they have included now, so the CPU offload. So
Okay.
we can also load your data to CPU. So that's set to true.
Oh, okay.
Okay, so then
Uh,
that is,
could
I
you
think
repeat
that
what
was
does
the
this,
problem you were facing.
could you repeat what does this do?
So because it's loading the data, right? So where
Uh,
is it loading? Is it loading it to the GPU RAM, or is it using the CPU?
CPU. Okay,
Okay.
okay.
So okay. So you are also giving it option to load it to CPU. rather
Oh,
than
okay.
just keeping it on GPU, because GPU
Then
we will
we,
store when we are,
yeah,
yeah. So GPU we will store when or we will use when you are using the training, right?
yeah. So the same
So
error
now
came.
it failed, right? Yeah, it failed.
Yeah,
So
yeah.
now, yeah, it failed because yes. Um, no, it did. Why is it saying that error thing? Okay. Yeah.
I
So
just
never
tried in
mind.
Kaggle and
Yeah, run it in Kaggle and
I'll
then
send
it
it to
should
you.
be all good. Yeah. So let
Okay.
me share my screen for a while.
Sure.
Let's show you. So okay. So this is on A100, right? So if I oh, load the JSON file. So you have to be careful when you are also using Kaggle, because these don't. I think you know by this time that these keys will not transfer, right? So you have to
Yeah,
put it in their
I have to actually
environment.
like I have to import token Hugging Face and then I have to do.
Yeah. So it's
Yeah.
maybe next time I will show how to. So the best way when you are coding is you don't expose these keys. Okay. So for example, I can I'll show you how to use it in Python, like .py code. How to keep it in the environment. So best to keep it inside the environment, and don't. I have also coded like those are wrong coding or not good standard of coding. I probably have some few of those also in my GitHub, but those are not good. So you should always keep those hidden. Okay. So anywhere you are using, it's a good practice to secure all these tokens. Okay, let's see what is going on inside this one. Yeah. Okay. In the meantime, and actually, okay. So anyway, so it started training, and finally it will calculate the perplexity. So, uh, yeah, so you have to use 1.1.42. So, yeah, so see, if you can notice over here, while it is training, it has already taken 26.5, right? So that's the reason your T4 is, whenever it's training, you cannot use T4. But with, I think I have provided a code for, uh, which one was that called? Unslot. The Onslaught will work with T4. So whatever models they are generating is more geared towards using in T4. Okay. So that's the reason you can definitely use unplug for that purpose. Okay, cool. So try this, everyone, on Kaggle maybe, and that way it will be. I hope this data set will work, or this notebook will work. Okay. Now, I also wanted to show you guys one thing. Show you. So, so whenever you are actually, no, this is not the right code actually. Um, anyway, maybe next week I can show this how. Yeah. So this is how you can put things in your environment. Okay. So while we are here, so I'll create a video for this for sure. But for now, I wanted to show you guys if anyone has already this thing Postman installed, or you have worked with Postman. So let me give you some code that you can work on. Okay. New window. Yeah, so let me take some time to talk to you about deployment, right? So all the while we are, of course, training our model, but how do you now create your applications, right? So you have to deploy your applications for sure. So this is, I gave you some idea of how to use Docker. So Docker is the best way to go about. And it's free, so you can also use it in any cloud or anywhere. You can just move it on premise or on the cloud. But this is a way you can actually use AWS. So in AWS, we also use Docker. So AWS at the behind the scene also uses Docker to import its code to Lambda. Okay. So this is called if I can. So anyway, let me just show you the last. Yeah, so this is how you can have, I hope this works. You can have, you can generate, yes, it's working. So see, if any one of you have this Postman installed, then give this to you. And then I'll speak about it. Here it is. So if you have your Postman open, so try to use the post method and then use this as your body and check that this is working for you. So this is how you can deploy your model to AWS. But how do you deploy your model? So there's a lot of steps involved in it, but let me show you how it is done. So what AWS does behind the scene is you simply have to provide a template like a Docker file to it, and you have to mention what are the requirements, which is your model. So notice this is one of a very simple text classifier model that I just saved it as PTH, and then you can have everything inside a folder, and this is basically using a SAM method. Okay, so that's very easy to use through AWS. And then you can copy your model PTH to a model folder that is created inside your Docker, and you can simply call the Lambda handle. Okay. So the Lambda handle is given over here. So Lambda functions are basically serverless. So that means that you don't have to specify which type of server to use, because of course PyTorch is a very how do you say, it's a very huge library. It's almost a GB, 1 GB. So if any one of you have any idea about AWS, so EC2 instance, the T2 micro, that's the free instance, is actually quite small to handle these bigger libraries like PyTorch. So if you had to mention earlier that how do you go about with using a server and all those things, it would have been difficult for I mean, who is not more accustomed to AWS, they don't understand which EC2 instances to use and all. So that's the reason any of these like any of these cloud architectures um, have provided you a serverless function. Okay. So what do you mean by serverless is that you don't have to bother about the server. So you just mention a Docker file. So it goes like this. So ECR, then AWS, and then this is the Dockerized image, and then it goes over to an AWS Lambda, and it deploys to a Lambda. And then when you are calling and it creates, so everything is taken care by AWS, and it also generates a what do you say? It also generates an endpoint for you. So you can have what is that? Like you can have a domain name for this. Later on, you can definitely attach a domain name, DNS name, of course, with this. But for now, it generates the inference or an API for you, which you can call through Postman, or you can create a what do I say, a JavaScript code or maybe a React code on top of this API. So whenever you are training a model, it's best to generate an API. It's best to deploy it and generate an API. So with that API, now you can create applications, different maybe desktop or phone applications. So it doesn't matter. But as long as you have those APIs with you, it's easier to create those kind of codes, right? So yeah, so here I'll let me mention a little bit about Lambda handles, actually handlers. So it takes a body, and then whatever you have given it as your, for example, like it takes the sentence, right? So it's kind of trying to classify a sentence. It's a very dumb model that I created over here. So there's nothing good about it. So you can then specify the path, then you can check if CUDA is available, but CUDA is not available because it usually works with CPU. So when AWS checks that it's a CPU thing, or it is working on CPU, then they can install that version of Torch, which is basically CPU oriented, not GPU. So that can also probably take a little bit lesser space for you to work on. And then you can try all your codes, like load your model, then put it into evaluation mode, and then you can use the sentence and then try to figure out the predicted levels. Okay. So this is simply like the test script that I have put over here. Okay. So this is so it's very easy. So if you are even if you when you have created your Hugging Face model. So I think in one of the courses, one of the notebook, I asked you to publish it to Hugging Face, right? So when you have a Hugging Face, for example, it's very easy to load. So I was testing with Hugging Face, for example. So notice you can, when you actually publish it to Hugging Face, so it will save your model.bin, then configuration JSON, tokenizer JSON, everything. And you can simply call all of these Hugging Face APIs or URL to your Docker file, and then you can simply use it inside your uh, inside an app.py and use it inside the Lambda handler to create an API. Okay. So this is kind of the if you so once you are done with your maybe fine tuning a model and you're saving your sorry your weights into Hugging Face, so you can give this a try. Okay. So and because your main goal is to create an application which others can use, right? So yeah, that's kind of the goal of this. Any questions on this? Guys want to know something more about this kind of deployment?
You just run this one.
Sorry?
Could you run the program?
I cannot at this point because it will take some time. So you have
Oh,
to
okay.
build it. Yeah. So let's
Okay.
see if it probably we can build it. So that's the reason I have to create. Yeah, I'll create a video. So whenever you are running a Docker, yeah, sorry. Whenever you are running a Docker, you should try to, or should always keep your Docker running on the back. Okay. So yeah, this will take some time. So anyway, there was no change as such. See this one, build or not. So build is actually creating a Docker, it creates a Docker image. Docker. Got hidden somewhere. Not, yeah. So I think I have to spend an entire class on this. Okay. So how to start from the beginning. So anyway, so let's just let me do this in some one of those Saturday classes I can pick to show you guys how this is done. But I was in the process of creating a video which I can share, so you can also try it out. So, but the problem here, it might if you are creating a trying to deploy it to AWS, it might cost you a little bit money, not too much. It usually is almost free, but it could be a little, it might ask you for a little something, which is very, at least in dollars, it's very small. I'm not sure, maybe it's quite less for INR also. Okay. So anyway, let me put this for next class where we can, where I can start from the very beginning to show you how it is done. Okay, so okay, so then the next few minutes I want to spend on going over. Yeah, so I think we did talk about three types of attention. So self attention, then masked attention, and then encoder decoder attention, right? So and then finally we also discussed about multi-head attention. So to go about these once again. So in an encoder only transformer, you use self attention, right? When it's a decoder only transformer, you use marked self attention. And in many multimodal models, you would use a decoder and encoder decoder transformer. Okay. So Yeah, so the encoder decoder attentions uses output from encoder to calculate the keys and values. Queries are calculated from output of masked self attention. So these are mostly used for, these are called cross attentions, and they can also be, they are mostly used for multimodal models, right? So you can have an encoder trained on images or sound and use encoders or use decoders to find its caption, right? So anyway, so I think this is fine. So far we have seen attention, yeah. So and then this is your multi-head attention. So far it was only a single query, value, and key, and that then we are duplicating this. We are using multiple heads for calculating attention because it can capture good context for your for your language, for whatever you're providing, right? Or for the context or the text that you are providing. And then you finally, you actually use a fully connected layer, and then it gives you the context or the context actually, the embedding context maybe. Okay, so there are a few ways you can also decrease the number of bits that you are training on this. Um, so reducing the size, maybe one of the ways is reducing the size. Yeah. So, but we are not going to deal with it yet. Just to know this can be done, but we are not going to deal with this yet. So for now, what we will do today is we are going to now code. So attention, so three types of attention we can actually use. You can code it into a simple class, like a class attention, right? And then we are going to code all the three types of attention with using a simple same class attention. And then here we can have so these are is all identical like the way we used it earlier. So the init method has a d underscore model, which is the embedding size, the row dimension, and the column dimension. And then we are actually initializing our weights for query key and value. And then you can save the row and dimension, column dimension, row dimension, and things like that. So this is how your instead of coding three different attentions, you can just simply use this. Okay. So but what we can do, because now we are using a more common example. So we are here using encoding for so earlier we were using just the encoding value, encoding of the token. So now what we will do is, instead of using encoding for token, we will just simply divide it into encoding for query, key, and value. And then must is none. So this is an option that we are keeping for the must attention, right? So that's the forward method. First, we specify encoding for query key and value. Second, we pass those potentially different encodings to the matrices to create query keys and values, right? So instead of the encoding values of the token, we are using the query key and value for this. Okay. Okay. Then these remains the same. We are calculating the similarity score using the matrix multiplication of query and token, query and key, which is transpose. And then you have to, then we are actually using the yield similarity. And if mask is present, you add the mask, fill the mask actually, and then finally use the soft map, right? And then multiply it with V, which is the value, and get attention score. So this is how, so instead of the way we were using encoding tokens, this, if you make this modification, this particular class can be used for any kind of attention classes now. So this one is the class. This is the class from next class onwards, when we will be now trying to start building our model. We will always kind of keep coming back to reference this class. Okay. So I'll keep it in my util. So we can refer it from our utils. So instead, it's better to have all those kind of classes which you will use more often to keep it in the util. So not always to expose all of these kind of classes in your notebook. I think you kind of have seen this good practices in many GitHub repos. So right now it is an ad hoc method of doing this, but we should also keep an eye open to make our codes much more easier to understand and also reusable, right? So these are not at this point reusable on your notebook, but we have to make those reusable too. So now let's create the encoding. So if you are creating the encoding, so we just I took same encoding value for Q, K, and V, just keep it the same. So every time we will use the random number generator, feed for the random number generator. That kind of gives you the same value always with all the random values coming in. And then you create an object for the attention class, pass the encoding to the attention object. So we pass this and then you get the attention value. So this is how you can work with it. So let me show this in the code. Okay, so here is my attention class with the init method. Then at the forward, now we calculate. Okay, so then we calculate the encoding. Encoding for QK model equals to 2. So these are 0 and 1 row and column dimension. And grad function. So this is what this means. Do any one of you know what this means in Torch? Any guess? So this is basically it's saying that when you are training a model, you need to calculate back propagation, right? So you need to calculate gradient. So it's saying that in this torch definition, you can use this to calculate your gradient. So you can
Ma'am,
either, yeah, go ahead.
is it like matrix multiplication something?
No, it's back propagation. So
Oh,
what is back propagation? So back propagation is you are updating your weights, right? So when you are writing your training code, so what do you do when you write your training code? So first you run your you take an input value. Hang on. Oh, no. I think I have it somewhere. So give me 1 minute. I'll show a notebook. Okay. Yeah. So this is basically backpropagation. So see, this is a training schema. So you put the model into training mode. So you mention that model dot train when you are training it, and when you want to evaluate it, model dot eval. So then I have a data loader. So this is an image with label. So I enumerate or I iterate through my train loader, which is my training data loader. And then here, then you actually, what I do is, so label, yeah. And then so this is my optimizer. So your optimizer is used to calculate our gradient. So we put the optimizer. So these are steps of how you can usually do your training schema, okay, or training mode. So you put the optimizers to 0 grad, and then I'm using these images to output a value. So if this is a prediction, so 0, 1, and 2, it will output some values, or if it's like a regression problem, that means it will output some probability numbers, right? So then I kind of figure out, then I would, so these, if these are output as a tensor, so 0, 0, 0, 1, 0, something like that. So like the digit kind of, if I'm thinking of a digits problem, then I have to figure out what is the predicted value. So let's say 0 and 1. That was shown, that probably, let's think of this 0 as 1, right? And then we have to calculate a loss. So we are calculating the loss, and then finally we need to backpropagate on the loss. So this is where your loss tensor. So we have defined a criteria over here. The criterion is my cross entropy loss. Okay. So how do you so you have defined this so how do you calculate the loss? So this loss is a cross entropy loss for this particular problem over here. And then the loss, which is now, so you calculate a loss, which is definitely a tensor again. And this tensor will look very similar to what it is over here. So it will, if you print that tensor, it will actually show up grad underscore function equals to backward. So so that you can actually calculate a backpropagation or backward or backpropagation, and calculate the gradient. And then finally, when you are updating your gradients, or sorry, updating your weight, you go over here and you put optimizer.step, and that way it will update your weight. Okay. And then you keep iterating through this, through your training module with the epochs and the data loader. So I think till now I haven't, I think the RNN kind of, yeah, the RNN notebook that I shared, I was mentioning all these steps. So take a look at that RNN notebook again. So whenever you are asked to train a model, not fine tune a model. So in fine tune, Hugging Face takes care of most of this stuff. Okay. But if you are asked somewhere to just to train a model, then this is your schema. You have to put your optimizers to 0 grad, and then you calculate the predicted value, calculate the loss with the criteria that you are using, and then do loss.backward. So that actually does the back propagation for you. And then finally optimizer.step, which will update your width. Because at the end of all of these discussions, what we want to do is train our model so our weights are more aligned. So what are these weights? Now these are the weights, right? So when I am talking about width, these are all the widths, right? So initially when you have nn dot linear, so these widths are randomly assigned, right? But as your training module proceeds, these widths have to align itself or tune itself in such a way that you can so you can actually or the loss between the train and the validation keeps decreasing more and more. Okay, so that's kind of the goal that the way it is trained on your training set should so the weights that are trained on a particular training set should also perform well on your validation set. Okay, so that's kind of the actual of the goal of any of these training modules. Got it. So take a look at that RNN notebook I shared earlier. There was a video, I believe, yeah. So take a look how I did that, and that's how you should always. Uh, it's like even when we are trying to train a LLM from scratch, we have to use this module. Yeah. Okay. So this is how. So now it kind of makes sense that these are the weights that we have to update, and these are encode. So these are the values. These values are always kind of my input values, right? So this is the input value that we passed into this object of the model. So the model, so here we created an attention object, right? So we define the D model equals to 2 row dimension column, and we created an attention object. And now in the attention object, we are passing this value to uh, get the values of our attention score, right? So yeah, so this is how we will go about creating LLM. Now let's go back to the multi-head problem. So in your multi-head problem, you everything almost remains the same. So you have an encoding value, embedding value, the embedding size, I would say, row dimension, column dimension. Then you have a head number. So here you have to mention how many heads. You can pass this as a variable. So just the default is 1, for example. So what we will do with the multi heads are in the init method we'll add one parameter, that is multi number of heads, the number of attention heads we want. Then we create a for loop for number of heads of the attention. So here we now define the heads. We start defining the head. So NN, that is neural network module from PyTorch, has a module list. So module list method available. So module list is nothing, it just gives you a list, and it has an index number, right? So it's like the way you would go from 0, 1, 2, 3. So it will give you a list. So here, all the attention heads that you have defined, so it's a for loop in range number of heads. So if it's one head, then only, so then populate it with only one head value. If it's two, then with two head values or any number of heads, you can populate with that, right? So the each attention model object that we create is to initialize with the same value as D, model, row dimension, and column dimension. And then, yeah, so actually, I think, okay, each attention, I think it's somehow got repeated. And finally, we save the column dimension, but this gives my module list. So this is for the init. And now how do you define the forward method? So forward remains the same, encoding for Q, K, and V, and mask equals to none. And then we use a for loop to pass each matrix. So here we have to concatenate or add all of these head values together, right? Each matrix to each matrix, sorry. And then we use a for loop to pass each matrices to each of the attention heads. Okay. So for head in self.head, and each of the attention heads are now concatenated together. The attention value is returned by each head is then returned. Yeah. And then we can check. So here we can check for one value, and then we can check for two heads, for example. So actually, let me go over the code. That's better. So here, class multi-head attention, and we have the number of heads here. Super.init. So this is calling the parent class of the init module init, and then create a bunch of attention heads. So for in the range of number of heads, and then we are saving the self.column dimension equals to column dimension. And then let's define the forward. So for this, we'll have encoding for Q, K, and V. And then finally, return the data to all the attention heads. So we add all the heads. So this is the head value which takes in the encoding for QKV for heads in self head. So that is calculating how many heads we had earlier, right? So it's calling over the number of heads here, and then just concatenate and return it. So if we want to just so this is a way of creating the multi-head attention, right? And then we pass this. So if my number of head is 1, for example, so this is again uh, just uh, just a 2 by 3 kind of 3 by 2 kind of the tensor size that is returned. So notice here it also mentions that cat. So cat is concatenated, right? So you can so this is very good in terms of PyTorch that it keeps kind of a history of what has happened to it. So we have done a concatenation, torch cat. So it just returns cat backwards. And then if we use number of heads equals to 2, so it just doubles up, right? See, it doubled up over here. So if you use 3, for example, definitely it will just keep increasing like that. And this is all the attention scores that is returned. Okay, I think the coding part, this one is quite simple for attention and multi-head. Now the difficult part comes in when we have to use this for creating mm, a kind of writing an LLM, right? So and training the model. So as you can see, we have to use the right optimizers. We have to use the right loss function. So that's what we have to keep doing. So when you have a training coming in, so it's very important to check hyperparameter. So that's when you use weights and biases. So as I was mentioning, I'm not sure if I can open my. So this here. So I will get an image. I'll get an image. Dashboard. Yeah. So you should. So this is, for example, this is all we have to now bring together. Okay. Yeah, so it will give you, so when we start using weights and biases, it will give you which model shows you the best IOU score, accuracy score, and some of the matrices that you want to log. Okay. So